All right, so I pulled in a picture of the unit circle. Obviously, remember you need to fill this out on Thursday's quiz. And highlighted in yellow were all the x values. So these are all your cosines. Highlight in the green are your y values. These are all your sines. And then I added on the tangents on the outside. So all the things that are written in blue are your tangents. Remember at the x-axis, they would be 0 because 0 divided by 1 is 0. On the y-axis, those tangents would be undefined because it'd be something divided by 0. And then every over 6 is root 3 over 3 because it takes 2 3s to make 6. Every over 3 is root 3 because it only takes 1 3 to make 3. And then every over 4 is 1 because the x and the y are the same. And then we also talked about the importance of the sign change as you move around last week. So this would be all students take calculus. And that tells you which of the original 3 functions are positive in each quadrant. So first quadrant, all of them. Second quadrant, sines positive, which means cosine and tangent are negative. Third quadrant, tangents positive, which means cosine and sine are negative. And fourth quadrant, cosine is positive, which means sine and tangent are negative. All right, so number 1 and 2 say find the point on the circle that corresponds to the real number t, then find the sine, the cosine, the tangent. So 7 pi over 6 is here. Okay, coordinate point there is negative root 3 over 2 and negative 1/2. So sine is negative 1/2, cosine negative root 3 over 2, and that's an over 6 in the third quadrant, which means tangent is a positive root 3 over 3. Questions on that one? I memorized them. Every over 6 is root 3 over 3. But if you want to go the long way, which you can, you don't have to memorize them. It's the y over x there. And then you'd have to keep, change, flip, and rationalize. So I think there's a benefit. I know it's memorization. I don't normally promote it, but then there's the application of it. This is the one thing I would say memorize the heck out of, is your unit circle with the tangents. All right, then 2 is 11 pi over 3, and 11 pi over 3 is not on my unit circle. It's too big. But if I were to convert that into a mixed number, this would be 3 2/3 pi. So we also talked about in 4.2 how to deal with odd and even whole numbers. We said the even whole numbers are on the right and the odd whole numbers are on the left. So instead of subtracting 2 pi to find coterminal angles, which you can, that's one way to do it, but the bigger the number, the more annoying that will be. The other method is take that 3, the 3 is odd, which means I'm going to start over here, and then move the remainder of that fraction, which is 2/3. 2/3 means it's not the 1/3, so it's not the first one you hit. 2/3 would be the second third you hit, which is in the fourth quadrant. And in the fourth quadrant, the over 3 is 5 pi over 3. So the coordinate point there is 1/2 and negative root 3 over 2. So my cosine, or let me go in the same order. My sine is negative root 3 over 2. My cosine is 1/2. And the tangent, it's an over 3. So it's root 3. It's in the fourth quadrant. So it's negative. Questions on that one? So again, Thursday you are going to fill out a blank unit circle, which means these points are probably not going to come directly from your unit circle. It's not going to say find the sine of 2 pi over 3. It's going to say something like find the sine of 11 pi over 3, where you've got to find that coterminal, or you have to use that trick I just went over to find it. All right, then 3 is asking, it says find the value of the trig function to evaluate the indicated function. This is our even odd functions. When the sign changes on the angle, which is what's happening here, it's going from sine of positive t to sine of negative t. This is where we have to know what's even and odd. So cosine and secant are even, which means when we change the sign, we don't change the sign on the trig function, but everything else is odd. So if the sine of t is positive 4/5, the sine of negative t is negative 4/5. We would change its sign. And the cosecant of t is the reciprocal of the sine of t. So this is 5/4. If it was the cosecant of negative t, now it's the reciprocal of the sine of negative t. So it would have been negative 5/4. And then the last two are just calculator based. Remember, the important thing here is making sure you're in the right mode. So for number 4, what mode do I need to be in? Radians. There's no degree symbol there. This would be 1 over the cosine of 4 pi over 7. Cosine And I get negative 4.494. Oh, it says 4 decimal places. 493. Oh, the 9 would bump. 40. And then cotangent of 35 degrees. My calculator has to be in what mode? Degrees. So 1 divided by the tangent of 35. 1.4281. Questions on those? All right, so we're going to move into section 3 today, which is right triangle trig. Okay, we start with hopefully review. The acronym SOHCAHTOA, we talked about it a little bit last week, but SOHCAHTOA is an acronym for your 3 original trig function ratios. So the SOH stands for sine equals opposite over hypotenuse. The C, that's the SOH part. The CAH stands for cosine equals adjacent over hypotenuse. And the TOA stands for tangent equals opposite over adjacent. So in this section, you're going to review like that kind of stuff, which hopefully we've seen before in geometry. We did SOHCAHTOA, right? We did right triangle trig. And then again, a little bit in algebra 2. And then you're going to get your 30, 60, 90, your 45, 45, 90 triangles. So all that stuff comes back in this section. And then the application word problems. So your quiz, I'm going to do it in 2 parts. There's just way too much calculator, leave it off. So I'm going to do it in 2 parts. Part will come straight from your unit circle and your non-calculator questions, like all the stuff that we just did based on that unit circle. The stuff from the first section that was like coterminal or arc length that you didn't need your calculator for. And then we're going to get into the stuff that's going to require the calculator, which is a lot of the right triangle trig stuff today. I'll kind of, when I go to a problem, I'll be like, this is with a calculator, this is not with a calculator, so you can get an idea. All right, so if I'm looking at a triangle on the left, like before you even get to the one on the right, if you look at the triangle on the left, this is a right triangle. If I wanted to find the ratios of theta, I could say the sine of theta is opposite, which is A, over hypotenuse, which is C. I could say the cosine is the adjacent to theta, which is B, over the hypotenuse, which is C. And I could say the tangent is opposite over adjacent, which is A over B. And then the reciprocal functions are literally the reciprocals of those. So cosecant would be C over A, secant would be C over B, and tangent would be B over A. So without a circle, or when I'm given just the right triangle, that's what it looks like. Now if I took that triangle and I put it inside my unit circle, and the unit circle has the radius of 1, this is the overlap with what we did yesterday. The sine of theta, say theta was here, it would be opposite over hypotenuse, which would be y over 1, and that's why it's y. The cosine would be x over 1, and that's why it's x. The tangent would be y over x. And the cosecant would be the reciprocal, 1 over y. The reciprocal here, 1 over x. The reciprocal here, x over y. So there's 2 ways to apply SOHCAHTOA. One is in any right triangle, and one is specifically in your unit circle right triangles, in which your hypotenuse is 1. So if I just asked a trig function of one of your special angles, your over 2s, your over 3s, your over 4s, your over 6s, okay, or your whole numbers, I use the unit circle stuff, y, x, y over x. If I am given any other angle, 32 degrees, 47 degrees, something like that, then I have to set up a right triangle and use the original opposite and opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. All right, so this just basically says trigonometry values for a given angle are always the same no matter how large the triangle is, which means the ratio of the opposite side to an adjacent side of a 30-degree angle, the ratio of a 30-degree angle in which this side length is 5, let's say, is going to be the same as a ratio of the side lengths if it's 30 degrees and this side is 50. The results for sine, cosine, and tangent will always be the same. They will simplify, okay? And that's why right triangles, special right triangles like 30, 60, 90, and 45, 45, 90 triangles always end up in the same ratio. So side lengths won't be the same, but the ratio of the side lengths would always be the same.
But what if the triangle above it was like 7?
It wouldn't matter.
Oh.
Yep, the ratio. So at the end, it's the ratio. No matter what, if you have because first of all, it has to be a right triangle, right? So this has to be, which means this would be 60 degrees at the top for both.
Oh, okay.
And then, I mean, we're going to talk about it in a second, but remember, like, you have the opposite 30 is 1, opposite 60 is root 3, and opposite 90 is 2.
A multiple of 5. Like it doesn't
No, it could literally be anything. It could be 41, and when I reduce it, it would always be, if I'm talking about, like, the sine of 30, it would always be 1/2.
Alright.
Yep. All right, so that's this kind of concept is built on not knowing the angle. It says find the value of each of the 6 trig functions if theta is 4 and c is 2 root 5. No, if b is 4 and c is 2 root 5. So this is just a generic right triangle. I know nothing about those angles. I'm not going to use my calculator. So how could I find that third side? Good, Pythagorean theorem. On any right triangle, a squared plus b squared equals c squared, where c is the hypotenuse, which is opposite the 90 degrees or the biggest side. If you don't have it, if you only have the sides listed, it would be the biggest side. So I know I need to find a. I would say a squared plus 4 squared equals 2 square root 5 squared. This gives me a squared plus 16 equals 2 root 5 squared is 2 squared times root 5 squared, which is 4 times 5, or 20. Subtract the 16. A squared is 4, square root. Now, if this was just an algebraic equation, what would be my answer? Plus or minus 2. But because this is a triangle with a side length, it would be what?
2.
Just 2. All right, now I find sine theta, cosine theta, tan theta, secant theta, or cosecant theta, secant theta, and cotangent theta. So sine is opposite over hypotenuse, 2 over 2 root 5. What happens to my 2's? They cancel and I get 1 over root 5. Can I leave it like that? Nope, we rationalize. Multiply top and bottom by root 5 and I get root 5 over 5. Cosine is adjacent over hypotenuse, so 4 over 2 root 5. This also can get reduced. This is 2 over root 5, but it gets rationalized to root 5 over 5. And tangent is opposite over adjacent, which would be 2 over 4, or 1/2. Now to find the reciprocal functions, I want to flip the originals. But if I rationalize the originals, I want to go back to before I rationalized to flip. So for cosecant, I'm going to go back to the 1 over root 5 before you rationalize. Otherwise, you're going to have to rationalize something you already rationalized. So this is just root 5. For secant, I'm going to go back to before I rationalize and flip it. So it's just root 5 over 2. And for cotangent, it doesn't matter. We didn't rationalize it. So flip 1/2 and I get 2. Questions so far? All right, now we're talking about 30, 60, 90 triangles and 45, 45, 90 triangles. So for a generic 45, 45, 90 triangle, the ratio of the sides is A, and A root 2. If it's 45, 45, 90. Any triangle that is an isosceles right triangle, so 45, 45, 90 triangle, will result in that ratio. Now, if those side lengths, let's say A said 5, then I would know the other A is 5. I would know the hypotenuse is 5 root 2. If I take that triangle and I give it an A of 1, which is what would happen in my unit circle, now I produce these measurements. So opposite 30 degrees, 30 is at the top now. Opposite 30 degrees would be 1. Over hypotenuse would be 2, and my sine would be 1/2. Opposite or adjacent to the 30 degrees would be root 2. Hypotenuse would be 2. Root 3 over 2 is the sine. Oops, I circled the wrong one. Is the cosine of that angle. And opposite over adjacent would be 1 over root 3, and that would get rationalized to root 3 over 3, which is the tangent of that angle. So you can do everything we did with our coordinate points, our x and y coordinate points from the unit circle, with a right triangle. If you are right triangle brained, then do it. If you are a unit circle and you understand that that is just your x and your y, then do that. You get to choose, okay? I tend to use unit circle. Like Miss Ferrier and I go back and forth on it. She loves right triangles and I like unit circle. But they both produce the same answer. So if you see sine of 30 degrees, you get to choose. Do I set up a triangle where 30 is here, 1, root 3, and 2, and find all of your trig functions that way? Or do you see 30 degrees as the angle that is pi over 6, and you know that's root 3 over 2 and 1/2 and root 3, and you set it up that way. So you get to choose, okay? Again, if you had your unit circle, I would say it was probably easier to do it that way, but you get to totally choose. Yep. So in the one that they drew here, yeah, but it depends on what the theta will always be in that little corner. So if I flipped it, like let's say I found this sine, which I'm going to do next. Let's say I find the cosine of 60 degrees, it'd be root 3 over 2, which is why this is here. The sine of 60 degrees would be 1/2, or the other way around. The sine of 60 degrees is root 3 over 2. The cosine of 60 degrees is 1/2, and the tangent of 60 degrees is root 3, right? So you can do it that way. The other triangle you can use is your 45, 45, 90 triangle. So let's say I was trying to find 45's sine, cosine, tangent. It'd be 1 over root 2 and 1 over root 2 for cosine and sine, and it'd be 1 over 1 for tangent. So this is important, and this is like huge standardized test stuff usually too. 45, 45, 90 triangles have those relationships, and 30, 60, 90 triangles. Opposite the 30 is A, opposite the 60 is A root 3, and opposite the 90 is 2A. That is for any right triangle. That's 30, 60, 90. If your radius is 1, now we use the unit circle angles. So it'd be 1, 1 root 3, and 2. All right, so this, obviously, these are your special angles, okay? Which means we can use either triangle or unit circle. So I'll do one with triangle, and I'll do the other with unit circle, okay? Let's do the first one with unit circle. 30 degrees would be the first angle after the x-axis, and the coordinate point there, which is b pi over 6, is root 3 over 2 and 1/2. And if we memorize our if we memorized our tangent, it's root 3 over 3. So what's the cosecant there? How do you find it? Flip the sine. Take the 1/2, flip it. It's 2. What's the secant there? It'd be 2 over root 3, which gets rationalized to 2 root 3 over 3. And what's the cotangent there? It'd be 3 over root 3, which gets rationalized to 3 root 3 over 3, which is just root 3, which makes sense because those are the two tangent values. Okay, so that's, oops, didn't mean to erase. That's one way to do it. The other way is draw yourself a triangle. Make it 30, 60, 90. And it doesn't matter where you put the 30, 60, 90 as long as you pick the right sides. Opposite the 30 is 1. Opposite the 60 is root 3. And opposite the 90 is 2. And we use SOHCAHTOA. So cosecant is the reciprocal of sine. Sine is opposite over adjacent. Opposite over hypotenuse. So opposite 60 is root 3. Hypotenuse is 2. If I flip it, I get 2 over root 3, which gets rationalized to 2 root 3 over 3. That's cosecant. Then I go to secant, and secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse. So adjacent to 60 is 1. Hypotenuse is 2. Flip it, and I get 2. Then I go to cotangent, the reciprocal of tangent, which is opposite over adjacent. Opposite 60 is root 3. Adjacent is 1. Flip it, I get 1 over root 3, which gets rationalized to root 3 over 3. So you can do every single special angle either way. And by special right angles, or right triangle angles, we mean 30, 60, 45. Questions on that one? All right, example 3 is your calculator. We're back to what we started the day with. It says use a calculator to evaluate the function and round your answer to 4 decimal places. So cosecant would be 1 over sine of 35. It's in degrees, so you want to make sure your calculator's in degrees. 1 divided by sine of 35, and I get 1.7434. Now we have not done 1 in decimal degree notation. We talked about it, but we haven't done a trig function. So this is 1 over the cosine. I don't need to convert this. I actually can write it in my calculator exactly like that. 1 divided by the cosine of 83. Remember your degree symbols in second apps, where that angle menu is. 15 second apps, single tick mark. And I get 8.5079. And then for cotangent, I'm going to do 1 over tan, pi over 7, but I'm making sure my calculator switches back to radians. And I get 2.0765. Yeah. Cofunctions are next, okay? And the whole point of cofunctions, and this to people is so confusing, but if you just understood it, it's actually quite easy. The whole point of a cofunction is to say that if I have a right triangle, and I know one of my angles, so let's say I'm looking at a 30, 60, 90 triangle. Let's say I only know the 30 degrees. How would I find the angle that I'm missing? So I know this is 90, right? Which means these two have to add up to 90 degrees. They're complementary, right? So if I wanted to find this other one, I could just subtract it from 90. Those two are complements. With me so far? Yeah. So the sine of one of them, let's say the sine of 30, opposite over hypotenuse, is equal to the cosine of the other one. Because it would all, to 60, this would be adjacent over hypotenuse. And they are the same thing. So all a cofunction says is that the sine of any angle is the same as the cosine of its complement. The tangent of any angle is the same thing as the cotangent of its complement. the secant of any angle is the same thing as saying the cosecant of its complement, and vice versa. All of this for that. The biggest thing is that, yay, if you understand that, B, the whole point is that you need to be able to see a question that says sine of 90 minus theta and know immediately that means cosine of theta. That's all it means. It is that angle written in a completely different way. But those are the same thing. So sine goes with cosine, tangent goes with cotangent, and secant goes with cosecant for co-functions. So if I said cotangent of 90 minus theta, what am I really saying? Tangent of theta. That's it. You'll see these again when we get to trig identities. But people tend to really overcomplicate these two. So here it's saying find the cofunction with the same value as the given expression. So the cosine of 20 is the same as the sine of what? The complement. What's the complement to 20? 70. The cosine goes with sine, right? So cosine goes to sine, and this I subtract from 90, and I get 70. And if you literally typed it in the calculator and you did cosine of 20 and you did sine of 70, it's going to be the same. Because the adjacent side to 20 is the same as the opposite side of 70. So the cotangent of 40 is the same thing as? Good. To me, these are like one of the easiest questions, and yet people will still miss them because they just don't understand it. So you're going to get a question. Understand it. Just use the matching one. Sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. And then if it's an actual value like that, then just find the complement. Yeah.
Is it going to ask you just like that, or do you have to like apply it?
No, that's it. Like there. Well, in a second you'll see a different way, but for these kinds of questions, it is straight up just like that. All right, use the given function values and the trig identities to find the indicated trigonometric functions. This time it's giving me values for trig functions. If those values are not a half or root 3 over 2 or root 2 over 2 or 0 or 1 or some combination of those, then this is no longer a unit circle base. This says I have to set up a triangle, okay? So if you think about it, cosecant of theta is 3. What would that make sine of theta? 1 over 3. Is 1/3 anywhere on my unit circle? No. So that says set up a triangle. So I draw a triangle. I put theta in the corner. It doesn't matter where you put it as long as you set it up the rest of it the same way. I tend to put it always in that bottom left corner, but it really doesn't matter. Sine is what we just found, which is opposite over hypotenuse. Now, if I go to secant, and this whole thing is there, this would be hypotenuse over adjacent, because secant is the reciprocal of cosine. And that says my hypotenuse is 3 root 2. But what I just drew, does that hypotenuse 3 root 2? No. So what could have happened here? It's rationalized. So what you found was rationalized, which means you have two options right now. Flip secant and re-rationalize it, or just solve your right triangle using Pythagorean theorem. You could do it either way. If I have two side lengths, then I'm going to come over here and I could just say 1 squared plus x squared equals 3 squared. 1 plus x squared equals 9. X squared equals 8. X equals square root of 8, which is 2 root 2. Or I could have flipped the secant as 4 over 3 root 2 and then rationalized it and then simplified it. And that would have been my, hang on. This is 2. 2 root 2 over 3. And that would have been my adjacent and my hypotenuse, which would match what we just found. But you do either way. I think Pythagorean theorem is easier, okay? But you could do it either way. So now I have enough information to get all the other parts. Cosine is adjacent over hypotenuse, or what we just found here, 2 root 2 over 3. And tangent is opposite over adjacent, 1 over 2 root 2, which gets rationalized to root 2 over 4. And then secant of 90 minus theta is the same thing as what? Of theta. Good. And cosecant of theta is? 3. Questions? This goes back to, again, this is geometry. So if my angle is not 30, 60, or 45, then I have to, it would be A, calculator base, and B, I have to set up my initial ratios. So if I have 32 degrees, which is the one that I'm given, and I want to find X, for example, I'm going to pair this with the one side I do have, and then one side I'm missing. So in respect to 32, where is 7.8? Opposite, and X is hypotenuse. So which trig function are you going to use? Sine. Sine of 32 equals 7.8 over X. I'm going to come back and solve that in a minute because I'm going to set up the other one. If I wanted to find Y, I still use 7.8 because I don't want to use a rounded answer I'm going to find, which is still opposite. And then Y, which is where? Adjacent. And which trig function is opposite and adjacent? Tan. And then I'm just going to solve these. So I can multiply both sides here by X, and I get X times the sine of 32 equals 7.8, and I divide both sides by the sine of 32. And my calculator is going to be in degrees. And I get X equals 14.719. It doesn't say what to round to, but most of these are actually nearest 10th. So I'm going to do that. And then for the second one, so let's say I had solved that first and I had this value. Technically, you have two choices when I try to find Y. I could use Y in 14.7, or I could use Y or 7 and 7.8. Why is it better to use Y in 7.8? The original one is not rounded, and we know it's right. What if you got the other one wrong, right? So that 14.7 is a rounded number, which makes it less accurate, but it also could have been wrong. So here I'm going to multiply by Y, and I get Y equals 7.8 over tan of 32. And I get 12.5. Can I check this? What should be true about those three sides? What should be true about the relationship between them?
They squared.
Good. 7.8 squared plus 12. Yeah, I knew what you were saying. 7.8 squared plus 12.5 squared should equal 14.7 squared. And maybe not exact because we rounded them, but they should get pretty close. Questions? Well, I'll stop there for today. We'll finish this tonight. But homework is, we'll finish it tomorrow. Homework, which will be due Thursday, okay? But it's a lot if you wait. Has two parts. It's got a WebAssign, which we did everything that you can do on that WebAssign. So you can do the WebAssign in total. And then the second part has the right triangle. It has like one like we just did, but it also has word problems. So if you want to save the PDF for tomorrow, that's fine, okay? But where we finish, you should be able to do your WebAssign. At least get some of it done.